I'm talking from the back row because the man of the hour is going to talk up front. I am so pleased, first of all, to welcome our alums to Alumni Reunion 2023. Hooray! And special recognition to our golden class, which is really a blue class, but they're golden today. The class of 73. How many 73ers do we have here? And also special welcome to the class of 63, which is out in Forst as well. And I know 68 is here, and other classes are here as well. And 66 is here, and the president of the Alumni Association is here, President Wax. Be nice to her. I am so delighted that Dr. Allen Pietrobon, one of Trinity's finest members of the faculty, has agreed to offer this very timely lecture. And he's not talking about Barbie. He's only going to talk about Oppenheimer. We'll have another whole discussion of Barbie at Trinity. Okay. Dr. Pietrobon, there he is. He's the author of a wonderful biography of Norman Cousins, who was the editor of Saturday Review, one of the original nuclear nonproliferation activists. A wonderful biography. If you haven't gotten it, I highly recommend it. It's on Amazon. You can go to Amazon right now and download it. So Allen has been with us for, you're in your 5th year this year? 5 years at Trinity, teaching in our Global Affairs program. He's a specialist in nuclear nonproliferation and peace building. And Allen, I am so grateful to you for doing this lecture today. So welcome, Dr. Allen Pietrobon.
Thank you. Well, thank you, President McGuire, for that generous introduction. J. Robert Oppenheimer, Julius Robert Oppenheimer, just by a show of hands, who saw the movie? All right, good. Okay, at least half. I will probably not give any spoiler alerts here, or spoilers rather, but I do want to say there are a number of ways that we can talk about Oppenheimer. We can talk about Oppenheimer, of course, as the subject of this movie, father of the atomic bomb. We could talk about Oppenheimer as university professor who mentored a whole generation of physics students, many of whom would go on to win Nobel Prizes themselves. We could talk about Oppenheimer as a public political figure after the war who was outspoken about nuclear weapons. We could look at Oppenheimer as his friends saw him, as a charming, brilliant man of unique intellect. Or as his foes saw him, as a caustic, arrogant, vile man with no social skills who was mean to people. And finally, we could, of course, look at him as a serial marital cheater and terrible absent father whose firstborn son, neglected firstborn son, went on and retreated to a quiet life as a cattle rancher, and whose daughter committed suicide years later. But to explore all of that, where I actually want to begin is I'm going to sort of talk at you for a little while. We'll have plenty of questions, plenty of time for questions at the end, so if you've got any, hang on to them, and we'll have sort of an open session. But I want to begin with one of the most impactful days of his life, the day that would go on to haunt the rest of his life. And to do that, to get us into the right mindset, to understand Oppenheimer and his era, I first need to take us back to August 1945. And I need to start with a little story here. Because it's August 1945, and tail gunner Bob Karen is counting. 7, 8, 9. He is soaring 26,000 feet above Japan, crammed into a shoulder-wide compartment at the tail of the plane, where his job is to operate the .50 caliber machine gun, pointing out the back of the aircraft. And he's flying a B-79 Super Fortress, the cutting edge of military technology. Now, normally, Bob would have some help. He would, typically this aircraft had 10 of these heavy machine guns sticking out of the fuselage in every direction to defend the plane all around from attacking Japanese fighters. But today, Bob is nervous because 9 of the 10 guns have been removed from the plane in order to save weight to accommodate the enormous bomb that they're carrying. He is the only gunner pointing rearward. If they do get attacked, they are dead. And so the B-29's engines roar, the vibrations pulse down its polished aluminum body, and Bob continues to count. 21, 22, 23. Now, he had begun his count the moment they released the bomb. And he knew when that happened, despite being facing backwards at the rear of this huge aircraft, he knew the moment that happened because freed from its 10,000-pound weight, the plane shot up like a spring was released. And so he counts. First Officer Paul Tibbets kept a tight grip on the controls, and he immediately executes an evasive maneuver that is designed to pull this plane up and out of the area as rapidly as possible, because nobody, not even the physicists who designed the atomic bomb, knew quite how big this explosion was going to be, or what would happen when the shock wave caught up to the aircraft. This aircraft can fly at 357 miles an hour, but a nuclear shock wave travels at 784 miles an hour. It's like those horrible math problems. 2 trains leave the station. This one is a plane leaves the area and a shock wave follows it, and when that shock wave hits the plane, they don't know if it's going to tear this plane apart. 40, 41, 42. From on board the plane, all Bob saw was a brilliant flash of light, which he thought had blinded him because it just sort of seared into his eyes. But when the light cleared, what he saw was this, real footage taken from the rear of the aircraft. What he had seen was a 4-mile radius of the city of Hiroshima evaporated, disappeared in a split second. And when the co-pilot looked back and saw what had happened, he is reported to have said, "Oh my God, what have we done?" Now, later that day, back in Los Alamos, Robert Oppenheimer was also troubled. The FBI, who had agents secretly tailing him this entire time, reported that when he was informed about the successful use of the bomb, he was, quote, a nervous wreck. He was reported to have been wandering through the halls of Los Alamos muttering, "Those poor little people, those poor little people." And in fact, his wife, Kitty, and he soon left. They escaped to their ranch that they had nearby in New Mexico. This is actually their ranch, just a beautiful spot, where he started writing some letters to friends. Now he can reveal what he had been working on. It's no longer top secret. And this gives us a perfect archival source into his thinking at the time, where in one letter he writes, quote, "We are at the ranch now in an earnest search for sanity. There would seem to be some great headaches ahead." Shortly thereafter, he writes another friend where he says, "We have made a thing, a most terrible weapon that has abruptly and profoundly altered the nature of the world. A thing that by all standards of the world we grew up in is an evil thing." End quote. He refers to this immediately after as an evil thing. And then when he returns to Los Alamos a week later, he quits. He resigns as director of the National Lab. Now this story of this, as in Oppenheimer's own words, this evil thing that he created, actually begins a lot earlier. You know, this thing that without him, as scientists who worked with him said, this probably wouldn't have worked without him as director of the National Lab. He is sort of the linchpin of this project. This story actually begins way back, before Oppenheimer is even born. And because I'm a historian by training, we need to do some history for a minute here. And so the story begins in 1895, when a German scientist named Wilhelm Röntgen discovers a new type of ray, which, because he doesn't know what it is, he uses it, he names it the mathematical formula, or not formula, I guess, symbol for the unknown. He names it X-rays. You know about these. You've heard of these before, I think. X-rays. And he did what any good scientist does, I guess. I'm not a scientist. But he immediately calls his wife into the lab and says, "Hey, honey, can you hold your hand up here while I shoot this ray at you?" And he X-rays her hand. That little blob is her wedding ring, which we now know, like, you do not wear metal in an X-ray because it, like, absorbs the radiation, but here we are. So he discovers X-rays, which, on one hand, scientists and doctors use to do incredible things. It's thought that by so this is 1895, it's thought that by 1918, X-rays save about 1 million lives. But there are other people, because humans are often awful too, who realize there's different power here that we could use. And that realization comes the following year, when another scientist working in Paris discovers that the natural element of uranium has immense power, that it radiates, it has so much energy, it radiates its energy just sitting there. You don't need to start a chemical reaction, you don't need to charge it like a battery, it gives off energy. It has immense energy density. So that was our history lesson, here's our physics lesson for a minute here. We're gonna cover all of the disciplines today. Everything around us has energy density. Wood has energy density. We know that because it burns. When you combust it, it releases its energy in the form of heat and light and some byproducts. It has 16, the measurement is megajoules per kilogram of energy. Glass has a very tiny amount of energy, 0.035, because it doesn't combust, it doesn't burn. Coal has 24 megajoules of energy density. This is why we have coal-fired electric power plants, not wood-fired power plants. Probably the most common thing, gasoline, 46 megajoules per kilogram of energy. We combust it to power our cars. What he discovers is uranium has 3.9 million megajoules of energy density. So powerful, you don't have to combust it or, chemically react it. It just gives off its energy. Okay, keep that in mind. Physics lesson over. We'll move on here. My point of telling you all this is it is in that last decade of the 1800s and the first decade of the 1900s where science in general initiates an incredible revolution in human life. Right at that time, Americans, a nation that got around on horseback, are transformed by the car, the internal combustion engine. A couple of years later, 1903, they are astonished by the advent of human flight, something people have dreamed about for millennia. And then, probably the most important scientific revolution, at least for this purpose, comes around 2 years later in 1905, when Albert Einstein comes up with E equals mc squared, this trite thing we've all heard of, but here's what this means. He revolutionizes the study of physics. I realize I just said physics lesson over. One more physics lesson here. Let me, very, very simply, I'm not a physicist, let me boil this down. What this means is what he discovers with his special theory of relativity is, do physics work differently? We know how it works on Earth under the impression of gravity, but does it work differently when you're dealing with vast distances and time and force? Basically, does the law of physics change in outer space across vast distances? And simply put, yes. The answer is yes. Things behave differently across vast time and distance than they do on Earth in like a human scale. And what this unlocks is other scientists saying, wait a minute, if physics is different at huge scales, is it also different at tiny scales, at atomic scales, atoms being the smallest unit of matter? Long story short, the answer is yes. Physics behaves differently at tiny, tiny scales and at huge, huge scales than it does under sort of like a human scale, which the system we had been operating on until 1905 is Newton's law from 1657, right? This changes everything. If you know that, this births what we now call quantum physics or quantum mechanics, the study of very, very small things. Once you know the laws are different, you have the key to the door. You can unlock things that you couldn't discover before. And so it is at this moment, I'm telling you all of this because in this world of vast, exciting scientific discovery, J. Robert Oppenheimer is born in 1904, the year before Einstein's revolution of physics. And Oppenheimer is one of those natural-born geniuses. We know that. But it's also true that he happens to be born in the right time at the right place. He is born in New York City. But if we really think about it, maybe he's born at the right time to sort of make use of his abilities, but in the wrong place. He's in New York. All of this science is happening in Europe. Germany, Britain, they are so far ahead of the United States. We are a backwater in scientific research then. There are only 4 national research labs in the US at this time. That would become over 1,000 after World War II when we realized, like, hey, this science stuff is kind of important for like people to learn. It's a research backwater. The Europeans are doing stuff American scientists haven't even heard of before. So he's not in the right place. But maybe he is at the right time, in a sense. And maybe he is at the right place, too, because he's born in New York City, and because he's born to parents who are unbelievably wealthy at this time. His father owned a thriving textile company. They lived in a fancy apartment on Riverside Drive in New York City. Just to give you some perspective, this is the building Oppenheimer grew up in. At that time, each floor of the building had only 2 apartments in it. They lived on half a floor of this building with like 18 rooms. They had live-in maids and butlers and servants. They had a chauffeur. They didn't drive. They had a chauffeur to drive their Packard touring car, which they then would take out to the weekends to their 22-bedroom Long Island vacation home right on the ocean, where they docked their 40-foot-long sailing yacht. And when young Oppenheimer turned 16, the birthday gift his parents got him was his own 26-foot-long sailing yacht. I probably got a plastic toy truck or something, I don't know. But like the point is, he is unbelievably wealthy, or at least he grows up in this uncommon luxury. And so that, that helps, obviously, but he's also just sort of naturally gifted. He is naturally smart, precocious. He skips ahead several grades. He has private tutors, including his father hires the curator of the Natural History Museum to personally tutor him. But like some children who advance too quickly, what he had in intellectual skills, he totally lacked in social skills. A young Oppenheimer is weird. He is eccentric. He is arrogant. He is self-absorbed. He's mean to people. It's sort of like unearned meanness. And because of this, he had no real friends growing up. He's kind of isolated. For college, he enrolls at Harvard. And as an undergraduate student at Harvard, he is weird. He is eccentric, he's mean, he's self-absorbed, he's arrogant, and he has no real friends. And most of all, he's bored at Harvard. He is very excited by the science he's reading about and only being able to read about that's happening over in Europe. Again, they're doing stuff we haven't even heard of yet. And that's what he wants to do. So he asks his Harvard professor to write a letter of recommendation so he can leave Harvard and go study at Cambridge in London, another sort of center of scientific research at the time. He wants to study under a guy named Ernest Rutherford, who was working on atomic technologies. Now, here's the problem. Oppenheimer, despite being smart, very smart, was an atrocious student. Like D-, just terrible, terrible student. If you had encountered Oppenheimer in your class in undergrad, whatever year you were here, or if he was here right in this right room right now, you would hate this guy. He would constantly interrupt. He would, spout off about things. He would, worst of all, get up from his seat, come up to the board, rub out what the professor was writing or cross it out, and say, oh, you could explain this so much better if you just did it this way instead. He would correct. He was so atrocious, dominated the discussion, that other students threatened that they were all going to drop the class unless the professor disciplined Oppenheimer, like shut this guy up, basically. They called him the child prodigy. No social skills, terrible student. His former professors described that his work was sloppy, it was full of mistakes. He just didn't care about the work. And so because of all that, his Harvard professor did write him a letter of recommendation. To get rid of him. Yes, please go across the ocean, Mr. Robert here. Please. Hey, that's not a bad idea. But this is my favorite part. This is one of these richly ironic moments in history where he writes, and I quote, "It appears to me that this is a bit of a gamble as to whether Oppenheimer will ever make any real contributions of an important character whatsoever." It's like, this guy sucks. He's never going to contribute anything. But he does continue. Quote, "But if he does happen to make any good at all, I believe he will be a very unusual success." End quote. Which is fair. I mean, that's right. He kind of sees this coming. But this far from glowing letter of recommendation means that Rutherford rejects him, but passes him off to a colleague instead. So he comes to Cambridge, but he's not working in the atomic field with Rutherford. He's working in a lab, and Oppenheimer hates labs. He is not good in this setting. He really struggles. He's clumsy. He would break equipment. He just doesn't have the focus to spend time setting up these complex experiments and then waiting for them to give results. He's too impatient for that. So he's really bad in this setting. He does, when he gets interested in something, he does some important calculations. He is brilliant, but he'll do something, as his former professor said, quick and messy, and then he'd move on to something else. He would never take the time to develop the ideas he was working on. And to put that in perspective, it took Einstein 9 years to come up with the theory of relativity. Oppenheimer doesn't have that kind of patience. He's never going to be an Einstein like that. But ultimately, he would leave Cambridge and go to the center of the physics universe in Germany. And it is there where he would thrive. In just 4 years in Germany, he publishes 16 scientific papers, which is an astonishing output for a 23-year-old graduate student. These are top peer-reviewed papers. Just amazing. He impresses everyone with his intellect and his productivity. But as I mentioned, he's messy, he's fast. what they say was his great talent was to absorb and synthesize massive amounts of information, pick a new project, do really important calculations on it, sort of like open the door for a new field of study, and then he got bored and moved on and just like left it. But what he did was this door he opened with these like primary calculations meant that people who came after him could now walk through that door, use his research, and many of them went on to win Nobel Prizes on research Oppenheimer had abandoned, had like sort of proved it was possible. One example was in the 1930s, he calculated mathematically, not using like telescopes, but he calculated mathematically that black holes exist in outer space. These things we've all heard of, black holes. And at the time, everyone's like, what are you talking about? Right? And it wasn't until 50 years later that we could, through radio telescopes and stuff, prove that, oh my gosh, he was right. This mathematical calculation actually is right. This thing he thought was out there is there. And people would win prizes based on his initial research. So because of all this, when he graduates in 1928, he receives 10 job offers and chooses Berkeley. This is going to be his research home. They are setting up a new quantum physics lab. We can credit Oppenheimer with bringing quantum physics to the United States as like the only person who studied this in America. So he sets up this new lab at Berkeley University. But kind of the story of his life is, at first, as a young, new, hire, inexperienced professor, he is terrible. He terrorizes his students. He, by all reports, would be really mean and cruel with his remarks. His early lectures were completely incomprehensible to people. He tended to speak in a really soft voice. He stuttered and mumbled a lot. And he himself would later say, and I'm quoting from him here, "I was a very difficult lecturer. I can't imagine how bad it would have been for my students," end quote. But then something changed. He learned, he grew, he got better. Because within a few years, his students came to love him, to adore him. He proved to be an amazing mentor to students. He would work with them for hours in office hours, working through scientific problems that they were stuck on. And his students sort of fell for him so much that he had these weird verbal tics. Whereas you and I, sort of the common thing if you're pausing or thinking is to say like or ah or something. He wouldn't do that. He would, in the middle of a lecture, sort of stop and pause for a long time to gather his thoughts. And instead of going like he would say nim, 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 nim. He would just mumble nim, 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 nim over and over again. That was his weird verbal tic. So his students started to be known as the nim, nim, nim boys because they would imitate this. They would like absorb this weird verbal tic. His students started to hate Tchaikovsky because Oppenheimer hated Tchaikovsky. And they just sort of emulated everything he did. And please don't do that for the students who are in here. Don't do that. He, in addition to transforming his teaching, it was at Berkeley where Oppenheimer finally found himself, sort of created himself. He found his home. He went from being this mean, arrogant scientific prodigy into a sophisticated and charming intellectual leader. The kind of guy you wanted to be around, the kind of person who had this like vibrant, gravitational pull about him, who when he was speaking to you, you felt like you were the only person in the world who mattered. And later, when he was recruiting people for the Manhattan Project, one woman would write, she said, quote, "I had never met a person with a magnetism that hit you so fast and so completely as his did. I didn't know him or what he did for work, but I thought, even if he was digging ditches, I want to work for him." End quote. And that magnetism, as you might imagine, worked especially well with women. He's a handsome guy, I think. He's sort of awkward, a little bit shy, and this tended to attract female attention. And it's around this time he starts dating a woman named Jean Tatlock, a young woman studying psychology who also happened to be very active, a card-carrying member of the Communist Party, which at the time, this is the 1930s, that was not uncommon. A young, progressive, activist would be attracted to the Communist Party. Oppenheimer loved Jean Tatlock, perhaps the only true love of his life. But it was his connection to Jean, this active member of the Communist Party, which would come back to haunt him and completely derail his life 20 years later. And it's interesting to think about. I at least like thinking about these hypotheticals in history. What would have happened if Oppenheimer had married Jean Tatlock? He proposed to her twice, and she said no. And if she had said yes, she would later say she regretted not marrying him, but too late. If she said yes, if they had gotten married, he never would have been allowed to work on the Manhattan Project. As it was, the Army was withholding his security clearance because he just dated her and knew her years earlier. He never would have been allowed. And this also would have changed Jean's life, because Oppenheimer, this is the midst of the Great Depression, but he's actually making really good money as a professor at Berkeley. He's making today's equivalent of about $80,000 a year in the midst of the Great Depression. But an inheritance from his wealthy father also meant that he could supplement his income to the tune of an additional $250,000 a year on top of his salary. He was not hurting for money in the Great Depression, and that's why he bought this 154-acre ranch in this beautiful part of New Mexico, not too far from where he's working. And it is this cabin that would transform his life, because in 1939 he meets another woman, Kitty Puning, at a party. She at the time is the unhappily married, I say that again, married woman of a professor which Oppenheimer worked with. They were colleagues. This is his wife. Robert and Kitty immediately begin an affair, which they don't even really keep hidden. This is sort of like the scandal of Berkeley at the time. And the next summer, in 1940, he invites Kitty, still married, to spend 2 months with him at his cabin in New Mexico without her husband. Just the two of them. And amazingly, her husband agrees, and it's like, I'm going to be busy with research all summer. Go have fun with your friend Robert. Go enjoy the summer. It's okay. So they go off to New Mexico. They spend the summer riding horses and up at this beautiful ranch. Summer ends. They come back home. Robert goes back to work, sees his colleague. How was your summer? Oh, mine was good. By the way, I got your wife pregnant. Womp womp. Kitty divorces her husband, marries Robert the very next day. So now they are married. But, and then we'll stop talking about his personal life in a minute, he continues to sleep with Jean Tatlock. He continues to date the previous woman, which this is the one spoiler, if you saw the movie, that is like sort of fleshed out in the film. And we know he also, after Jean, carries on another long-time affair with another woman who's also married later in his life. So those are the two we know about. So not a great husband. Not really not great. But in any case, if we zoom out for a minute here, 1939 is a very eventful year for Oppenheimer. He meets his soon-to-be wife, Kitty. He's still dating Jean. And, almost more exciting than that for him, in January of that year, German scientists figure out how to successfully split the atom. How to take this uranium, which we've known since 1896 harnesses immense energy, and there are theories about if only we could find a way to take that energy and get it to be released all at once, then we could have a bomb. It takes until 1939 before the Germans figure it out. This thing that people thought wasn't actually possible, they do it. Oppenheimer thought splitting the atom, creating nuclear fission in the technical sense, was not possible. Then he learns they did it, and within 15 minutes, he figures out how they did it. This is, again, he can synthesize this information and figures it out 15 minutes later. They're able to replicate this experiment. And within a week, somebody reports walking into Oppenheimer's office where he had this big blackboard and seeing that he had sketched out the formula for how to build a nuclear bomb, that he had put this all together and sketched out a working bomb prototype. Now, it just so happens, as I mentioned, if you picked up on it, that this is 1939, and these are German scientists. And if you know your history, that's a problem, because this guy is in charge of Germany. And we know, or the scientists at least know, what's going to happen if Adolf Hitler gets the world's most powerful weapon, a super bomb. They are terrified about this prospect that this happened in Germany. They think they're working on nuclear bombs at this time. Now, and I hate to say this, don't take this the wrong way, there is one good thing about Hitler being in charge of Germany. One good thing. Because of that, we get this. We get Einstein, who is working in Germany at the time, and when Hitler rises to power, he's like, I am out of here. I see what's coming. I am leaving. And he effectively becomes a refugee. This is his immigration paperwork to enter the United States, where he flees. He openly says, I will never go back to Germany under Adolf Hitler. The Nazis put a $5,000 price on his head for someone to kill him because he's taking the scientific knowledge with him. And he lands in Princeton, New Jersey, where he works at the Advanced Institute there. And it's also, because of Hitler, we get a couple of other nuclear physicists who flee Germany in the advance of World War II, namely another guy named Leo Szilard, who works with Einstein. Because of all the people, it's Einstein and Szilard who know what it means that the Germans have nuclear fission now. So in fear of this, and knowing that the US is so far behind in nuclear and just scientific technology in general, the two of them write a letter to President Roosevelt, where they explain, you probably can't read it, that hey, in case you hadn't heard, here's what the Germans have done. We think they can use this to make a bomb, and we really think the US should be working on this too. And they mail this letter off, and if you can see it, notice the date, August 2nd, 1939. 29 days later, Hitler invades Poland. World War II breaks out. And in the melee of that letter is put aside. It doesn't actually get to Roosevelt for a month later. And when it gets to Roosevelt, to sort of simplify and paraphrase here, he says, yeah, I'm not convinced. I'm not convinced the US should be working on nuclear weapons, partly because A, we are not in this war. We are neutral at this point. B, it's the midst of the Great Depression. We don't have money to just pour into some pie-in-the-sky scientific research that many scientists are saying isn't actually going to bomb, and even if it could, it's going to take a decade. 3, even if we were in this war, we're going to use the limited money we have to build the things we know work, like tanks and bombs and aircraft. But he does say, but thanks for writing to me, Einstein. I'm getting my history mixed up here. Einstein, here's what we'll do. We'll fund some of your research. And he cuts them a check for $6,000. Even back then, that $6,000 then it's nothing. It's still nothing. But they don't stop. These scientists who are working largely at universities, fun fact, including right here at Trinity in 1943. There is one faculty member, courtesy of Sister Mary, who helped me out in the archives here at Trinity, who was secretly working on nuclear research technologies here in our chemistry labs, right? Sort of on the site of the building that used to be right here before. So these scientists are working on this at their own universities, sort of detached, working on their own little piece of it. The professor who worked here then got tasked to the US government on loan from Trinity to work more on this project. She eventually, not to go down the rabbit hole here, but she comes up with, if you know about X-rays, you also probably know about carbon dating and like carbon-14. She helps discover that you can use these like radioactive decay to date things way, 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 way back in history. So that's like her contribution to nuclear physics. This was Rona? Elizabeth Rona, yeah. Elizabeth Rona. There's a file in our archive here on her that I read through. It's really fascinating. So connect with. Yeah, it was not. Yeah, those of you who are here know this. Yeah, it's not the Advanced Institute that's like massive. Yeah, like this is, but they're doing this work right here on this campus, which is really, really fascinating. Then, again, not to go down the rabbit hole, then there was another faculty member who worked on the Manhattan Project who later joined Trinity's faculty in the late 50s, early 60s. But anyway, that was a fun fact, trivia, Trinity trivia here. So, where were we? They give them $6,000. It's nothing. And they continue their work until, another year goes by, and then, dun, 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 Pearl Harbor is bombed in December 1941. Now, we are in this war. Now, there's a lot of urgency to develop new weapons. Now, we have been dawdling for 3 years while the Germans, we are certain, are near completion, are right near a bomb. Now, Oppenheimer himself is convinced the Germans are close to getting a nuclear weapon and we need to do something about this. And so long story short, the US government centralizes a research facility named the Manhattan Project in mid-1942. And at first, it is unclear that Oppenheimer is going to be the director. In fact, he is not recruited for this. He's got too many communist connections. But more importantly, he's just not a good scientist. He's not won a Nobel Prize. He's prominent, but he's not that prominent. He's kind of a lightweight at this time. But eventually, the other scientists lobby the U.S. government. They're like, you got to pick Op. Like, if you've been talking to Oppenheimer, that's the guy who's got to run this. And at first, so he ultimately is selected as the director of the National Laboratory. And it's a large part because of him that this laboratory is sited in Los Alamos, New Mexico. Why? Because it's near his ranch, and he can go there on weekends. He doesn't want to be in New York City or where it originally started, or Chicago, or even California, where the other parts were. There's another lab in Washington State. He doesn't want to be there. There's another lab in the backwoods of Tennessee. He definitely does not want to be there. So he picks New Mexico. And at first, he really, really misjudges this. He says that just 6 scientists, joined by some engineers and some technicians, can do the job. And our budget should be $300,000. Within a year, to show how much they didn't quite realize what this project would entail, within a year, there aren't 6 scientists. There are 3,500. Plus 4,000 civilian workers sort of attached to it, plus 2,000 military security guards to keep all of them secret in there. And their initial budget went from $300,000 to $1.3 billion. Just a small rounding error there. Just swells. All of these people, they have to build a city from scratch in the desert of New Mexico. They built 300 apartments, 52 houses, 200 trailers for all these people to live in. Because if you get recruited to work at Los Alamos, you usually cannot leave. You are locked in because this is high security. Only Oppenheimer and a few others get to come and go freely. And even that is problematic to the security services. So this starts June 1942. And here's the maybe tragic, maybe that's not the right word, but here's the irony. We launch our program because we are convinced the Germans have a nuclear bomb or will soon. But what we know, to be clear, what they don't know, but what we know now, is that a couple of months earlier, the German nuclear project, which they were working on, they decide is not going to work. We're pouring this money. We've been researching for years. This is going nowhere. Shut it down. And they cancel the German nuclear research program. I think it's 2 months before we launch ours because we think they're working on it. And we don't learn that until 2 years later, that this whole time they have not been working on nuclear weapons. So we got time. One side note. The Germans cancel their project, and they take all this money they had for it, and they decide, well, we're going to invest in some other weapon system. What about rockets? What about near-orbit rockets? So rockets can basically go up to space. And they develop these, and they work, and they are highly successful, first as weapons launched against England. And then after the war, or rather as the war ends, the US military realizes there are a whole bunch of like German rocket scientists out there that we don't want to fall into the wrong hands. Let's go kidnap them. We launch a mission to kidnap these German rocket scientists. We bring them to the United States, and again, sort of summarizing, make them work for NASA. And it is because of Nazi rocket scientists, one argument says, that we got to the moon. That the technology we used in the Apollo missions comes from this research the Germans did in World War II. Anyway, back on target here. Not rockets, but nukes. So these guys are working in Los Alamos, and to give a bit of sense of what they were up to, they worked. They worked 6 days a week with only Sundays off. But Oppenheimer also encouraged them to work hard, but also play hard. And they would have legendary alcohol-fueled parties. Oppenheimer loved to drink. His wife loved to drink more. And there are lots of stories for even if at like 9 in the morning you came over to Oppenheimer's house to talk science, the first thing that would happen is he'd open the door and he'd thrust a martini in your hand to talk science at his house. And the reason he encouraged them to work hard and party hard, and his wife would complain that their alcohol budget was higher than their food budget. But Los Alamos was this hopping place. It was also a young place. This shocked me when I learned it. The average age of a Los Alamos scientist is 25. 25. Physics is a young man's game, they say. It's kind of like an Olympic athlete. You do your best work when you're really young in the field of quantum physics, and then you kind of age out. The reason Einstein is not working on the nuclear project, partly he doesn't want to, but partly he realizes I'm too old for this. Like this is a young man's game. I'm aged out of this. And it's also a young woman's game. Yeah. And so you can see there's some I think, yeah, there's some women on here. What Oppenheimer was good at was, of the 3,500 scientists, he recruited 600 women. He didn't care, man, woman, like if you have the knowledge, you come work for me. Like there's gender equality here. 600 women. He often, and this was depicted, unfortunately the movie shows only a single woman in like the whole movie aside from the women he's dating. There's a lot of them, and Oppenheimer, the army didn't want them working on the physics side of it. They wanted them to be secretaries, and Oppenheimer's like, no, I'm not wasting your knowledge to type up my reports. Get in there in the lab. And they were part of this. 600 women. There's another picture of them at the Tennessee lab. Tennessee lab. He did, though, if we're being fair, less well on racial diversity. There are no people of color working in the Los Alamos lab. And over the other 2 labs, which he's not technically overseeing, there are 11 African-American scientists. 11 of about 3,500 and none at Los Alamos. So less well there, but sort of at the time amazing in the terms of recruiting women for this. And so socially, at Los Alamos, a number of these scientists, these young 25-year-old, 20-somethings, would talk about how their time there was the best time of their lives, both because of the incredible sense of camaraderie, working on this patriotic project to help win the war and support the country, partly because of their wild partying. This is just like a fun place to be. Your mind is opened by this incredible research, and you're hanging out and having fun. And since there were so many young men and young women living and working and partying together in an era before effective birth control, you can see where I'm going. It is unsurprising that there are also lots of babies at Los Alamos. 80 are born the first year, 120 the next year. And the Army complains to Oppenheimer about, why are all these young female scientists getting pregnant? This is supposed to be a strictly scientific research project. And he, in his way, tells the Army, the duties of the scientific director of Los Alamos do not extend to providing birth control. That is not my job. That's above my pay grade. Partly, he allows, quote unquote, this to happen because the only thing that matters to him is getting a bomb before the Nazis. And he thinks if we don't allow people to get together, all these young people who are locked in here, they're going to quit. They're going to leave. I'm going to turn a blind eye to this whatever you're upset about. There's got to be a social life here at Los Alamos too. Now, as I mentioned, the irony is the Germans don't get it. They aren't working on this. We don't know that until near the end of the war. And so I could talk for hours about the scientific minutia and all of that, but let's, all the things they worked on, but let's dispel one myth, and then we'll start to bring this to a conclusion here. The myth, in my opinion, is that Oppenheimer is the father of the atomic bomb. He didn't work on this project. He didn't do any of the science on this project. He's not in the lab. He's the CEO sitting up in the C-suite while the grunts work down below. He would pop in the labs once in a while, talk about their research. He complained that he spent most of his time dealing with petty personnel issues and personalities and, dealing with the Army and security services. His, fingerprints are not on this bomb in that way. But the scientists do say that without him guiding them, and what he was excellent at was in this this field where you have big scientific egos, let's put it that way. Guys who clash a lot about, the research, about the right way forward. He could step into a meeting and say, synthesize it, say some things that made it very clear to everyone what the right path forward was. So he was sort of the arbiter of these discussions. And then, after about 2 years of work, and ultimately, when you tally it all up, 130,000 scientists contribute research to this project from Canada, Britain, and the US. 130,000. They, by July, have completed it. They have built a working bomb. A bomb that they have to cart out to the desert and test. You're watching footage of them assembling the bomb for the test. And then they have to use it. And the problem is, not only have the Nazis not got a working bomb, the war is over in Europe. The Nazis surrender in May. This isn't ready till July. It's ready too late to be used against the country they were going to use it against. But Japan is still fighting. And despite this, a lot of scientists complained that they were in this project, a lot of them were Jewish, they were in this project to defeat the Nazis, and now they're defeated. We should not be using this. But only one single scientist quit, resigned in protest when it became clear that we're actually going to use it on Japan instead now as sort of a consolation prize, as a backup here. Oppenheimer is depicted in the film, at least, as being sort of morally troubled by this, but he wasn't in reality, not at first. He thought deeply about the implications of the bomb. He was also deeply involved in picking the targets. He was deeply involved up to the last minute in tweaking the bomb so it would have more explosive force when it went off. He was in it. And the reason was And he argued to use it. He kind of shut down the other scientists who were arguing to not use it or to tell Truman to do a demonstration and not actually drop it on the city. He shut all of that down because his biggest fear was if the war ended and the U.S. didn't use a nuclear bomb. Here's what he thought. Here was his reasoning. If we don't use this bomb, we're going to have it on the shelf. But we're going to have no sense among the people of the world of what this can do to a city. And so what I want to have happen, Oppenheimer, is use it, blow up Hiroshima, show the world how horrible this bomb is, and then the world will be so terrified of the implications of nuclear weapons for the future that they will band together and ban nuclear weapons. Which you might think is like lofty, idealistic thinking. But he has a good reason to think this because this is what happened after World War I. The use of chemical gases was so horrifying that they made a treaty banning the use of chemical weapons. And I guess they have been used since in Syria, but that is the red line, not to use the Obama term, but like the red line of you can do anything in war, you do not use chemical gases. He thought that's what would happen here, that this would lead to international condemnation coming together to end these weapons. And he thought that if we had one without it being demonstrated, a future president would use it in a war. And by then, they'll be much more powerful, and we can't trust future presidents to be thoughtful about these sorts of weapons. So whatever you I kind of agree with that in a way. It's problematic, but it makes sense for Oppenheimer at the time. And so on August 6th, 1945, at 8:15 in the morning, this is Hiroshima before, a single plane dropped a single bomb and changed the entire world in an instant. A radius of 4 miles of the city is completely flattened, but for a couple of concrete structures that remained standing. We don't know still the exact number, but about 80,000 people are killed instantly. Ultimately, more than 120,000 would die of radiation poisoning and burns and stuff they suffered after. The heat of that bomb reaches 4,000 degrees, which is what, anyway. And on that note of if we're talking the moral implications of Oppenheimer thinking, no, we have to use it, there was one moment where before they detonated it, when they were setting up for the test, they realized that there's a problem. They did some calculations and they thought that when we detonate this bomb the first time, the temperature it creates, which we don't know how big or how hot this is going to get, it could get so hot that it causes a chemical reaction in the air that separates the hydrogen from the oxygen. So in water molecules, H2O, if you separate those through this chemical reaction, I'm not a scientist, don't know exactly how that works, but this can happen if you catalyze this. Hydrogen and oxygen, in the form of their own elements, are highly flammable. And if we push that button, we could set the entire Earth on fire. All of the oxygen in the air will burn up and the Earth will become another sun, effectively. And they ran these calculations. They were scared of this. And they came up to the conclusion that it's a very low likelihood of that happening, but it's not zero. Not zero. It could happen. And they went ahead with the test because, as they would later say, if it works and we don't blow up the world, hooray, we have a working bomb. Now we can end the war. If it blows up the entire world, then we're all dead anyway, and so we're not going to get in trouble. We can wipe out all life on Earth, and it won't matter because then humanity is over. And they went ahead with this. So our final points here, the story I started with, as I bring us to a conclusion, Oppenheimer returns after he learns of the successful use. He quits being the director of the National Lab. He basically never works in physics again. He goes to the Advanced Institute in Princeton. He doesn't go back to teaching. He says he can't teach anymore after this. He is tortured by the use of the bomb and sort of what it did, and especially the fact that what he thought would happen, the world didn't rally. We didn't get rid of nukes. In fact, we made bigger, more powerful ones, which he was fundamentally against, which he would, ultimately lose his security clearance over because he kept speaking out against developing more bombs. But he was, for the brief period, the most popular, most famous scientist, maybe even the most famous person in the world. And this is where we started. When he returns to Los Alamos, they do a ceremony to honor him before he quit, or I guess he's quit, and they're going to give him his send-off. And he gives a speech where he says this. Today, our pride must be tempered by profound concern. If atomic bombs are to be added as new weapons to the arsenals of a warring world, then the time will come when mankind will curse the name of Los Alamos and Hiroshima. And there was one man, our final point here. One man, while the rest of the country was celebrating, as the government put out the story that we dropped the atomic bomb, the Japanese were so scared because we threatened to keep bombing them with these that they surrendered. And the American population believed that. A survey in August 1945, just days almost later, said 85% of the US population approved dropping of the atomic bomb. But that very evening, which was technically the next day, so August 7th, when Americans were informed of the use of the nuclear weapon, that very evening, one man, Norman Cousins, and for our conclusion, I will switch into a shameless plug about my own work now here. He read about this in the New York Times, and he went and he wrote an article. He was the young editor of the Saturday Review of Literature, a small, stuffy New York literature review that had only 22,000 subscribers at the time. It's nothing. And he, in this moment of elation, he was scared. He sort of saw what the future would bring. And so he wrote this article that stuck with people. Today it went viral. This magazine that had only 22,000 subscribers, 40 million people read this article by the estimates. It just was reprinted and circulated everywhere because he's the first person to say this use of atomic weapons should not be a moment of elation. We didn't win the war because of it. We basically started the next war. That he goes on in sort of this prophetic way to talk about how nuclear weapons are not going to remain a secret. We might be the only people right now who have it, and the US government is saying these are going to keep us safe, but someone else will get them. And when that happens, it's going to spark a massive arms race. We're going to then race to develop bigger and more powerful weapons. When that happens, we're going to, not that we will, but people who control nuclear weapons are going to be tempted to use them to threaten and blackmail other countries. And because of that, we're going to live in fear of nuclear war, nuclear attacks. And eventually, as these weapons get more and more powerful, right now, what we dropped on Hiroshima was a crude prototype weapon that was pretty low powered comparatively. But these are going to get bigger. These weapons for World War II were designed to wipe out part of a city. In the future, they're going to be designed to wipe out countries with one strike. And all of that came true. He predicts this. And this is a very unpopular position he takes in 1945. But this man recognizes right away that this is going to be a problem. And then he devotes the rest of his life campaigning against nuclear weapons. For just one example, and then we'll wrap here. He, in 1949 and then 1955, he travels to Japan, launches a program to help treat women specifically who had been scarred by nuclear weapons. If you get burned by a nuclear bomb, again, to put it simply, unlike a regular burn, radiation burns don't heal. They remain open wounds, and they are horrible. And you can see these sort of open scars. This is 10 years later in this woman in Japan. And what Cousins discovers when he's in Japan, the US government has set up, right after the war, a research institution called the Atomic Bomb Casualty Commission. It's in Hiroshima. It's very ominously up on a mountaintop, sort of like overlooking the city, where they are requiring anyone who has any sort of radiation burns to show up, because they're under occupation. You must show up once a month to be inspected, we'll put it that way. We're going to examine you, but we are not going to treat you. We're going to examine you to figure out medical technologies to treat radiation burns, but we're not going to give it to you. Why, he discovers? Because it is the US government's policy to see what happens, see how untreated radiation burns progress, so that in the event of a future nuclear war, we will have the treatments available to know how to treat every stage of this disease, and we're going to know that by not treating you. And Cousins thinks this is disgusting, reprehensible. These are doctors doing this, and this is against their Hippocratic oath. You were required to offer treatment. So he launches a program to get treatment, get these women treatment. He brings them to the United States, gets them plastic surgeries and other medical treatments. And so to conclude, this is sort of the work when I discovered this guy in my own work 12, 15 years ago, however long it was, and became fascinated by this activist, this sort of, at the time, unknown, regular person, ordinary person who went on to do extraordinary things. He's one of the rare people who truly did make the world a better, safer place. It's because of him we get the first anti-nuclear treaty between the US and the Soviet Union, the Limited Nuclear Test Ban Treaty. He works on that in the 1960s. So I will end there and just say, if you want to know more about Oppenheimer, the movie was based on this book here, which is a Pulitzer Prize winning book. So if you're interested, it's about 800 pages, but it's worth the read. It's great. So thank you. Thank you very much, everyone. We do have time for questions, so yeah. Yeah, so yeah, the
It sounded like you would say we either drop it, we either use it, or what do we do with it? So what would they have done with it?
yeah, two great, I'll give you two answers. Great question. I'll just repeat it there's a live stream here too, so for the mic. That's okay, the next person I'll give the mic to. So like what would have happened if they didn't use the bomb? If they wanted to like, get rid of this, it's too powerful. Oppenheimer's fear was they're not going to dismantle. So like, yeah, you can take it apart, you can dismantle it. It's what we do with our current nuclear weapons we're decommissioning. That's problematic for a different reason, but yeah, but like he feared we're not going to do that. We're just going to keep them on a shelf somewhere and then use them in the next war. But here's the other thing. In Nagasaki, the second bombing, the rules of engagement were the pilot must visually confirm the target before they can drop the bomb. They're testing this, you want to make sure you hit the right target so you can measure it properly. And in Nagasaki, the bomb landed like 2 or 4 miles off target. And this is because, so the rules of engagement are, if you fly over Nagasaki and it's cloudy and you can't, because we don't know the weather back then, and you can't see the target, you have to turn around, come back, and ditch the bomb over the ocean because you can't land. It wouldn't have exploded. You don't arm it. You just like dump it in the ocean. Dump it. Yep. It just sits there. They might have tried to recover it, but probably not at that time. This has actually happened a lot. A lot of planes have dumped nuclear bombs over the ocean because they encounter mechanical problems or something, and you cannot land with a nuclear bomb on board. 42 seconds. Yep. Yeah, so it falls for 42 seconds. So here's the thing. They fly over Nagasaki. It's cloudy. They circle for a while, hoping the clouds will break. The clouds don't break. They're running low on fuel. They have to return home. And the pilot, in my opinion, my humble opinion, lies and says, yeah, he said, miraculously, like a part opened in the clouds and I could see the target and I dropped it. Yeah. Yeah, so it's in the 60s when the documents come out and we discover this. So the pilot, we suspect, we guarantee, lies about this because he doesn't want to waste a bomb because we only have 2. That's the other thing. The US government lies to the Japanese and says, if you don't surrender, we're going to bomb you every other day with a nuke. We didn't have any more. And we weren't going to have one for 30 more days. So they didn't want to waste this. They drop it over what they thought was the city because they were circling it, but it lands way off target, which actually saves lives because it lands in a mountain valley and kind of contains the explosion. 100,000 still die, but it would have been much worse. This was a different sort of city layout. So yeah, it's, this is what they're doing at the time. The thoughts, questions? Have I ever been to Hiroshima? I have. And Nagasaki? Yeah. So, okay, maybe I'll show you one more thing here because this, I think, is important if we're going to talk about nukes today, too. So I've been to Hiroshima. It is a thriving metropolis today. It's 400,000 people. You would never know the city got nuked 70 years ago. But that's because, one, this is a crude, low-powered device. And back then, these devices did not release all that much radiation. The radiation poisoning happens like immediately, but today, Hiroshima's safe to live in. Modern nuclear bombs release a ton of radiation. So much like Chernobyl, we now know from Chernobyl that like a modern nuclear explosion, it will be about 900 years before...
A few weeks ago...
Oh, wrong thing. Sorry. Let me go through here.
Hey, Shark.
Yeah, so it'll be about 900 years. So if this were Hiroshima today, 900 years before it is, habitable by humans again. And here's what I want to show you. If this will pop up in a second. About 900 years. If we nuke a city today, humans can't live there for 900 years because the radiation now like sets in. Here's the thing. Not to give you nightmares, but I've been to Hiroshima. Here's the map I drew. If that same bomb, a 15 kiloton bomb, were dropped on the White House, don't get me arrested. There's the White House. Everything within the red circle is flattened. Trinity is right there. If you can see my little red dot. The little red dot, we're dead too. We're right on the edge here. Capitol building, White House, Pentagon is down here in the left. That's what a Hiroshima bomb. So part of it boils off because it is 4,000 degrees. Hiroshima also had a river, much like this. It had this Y-shaped river. The people who got radiation burns jumped into the river because your skin is on fire, and that got infections and all kinds of stuff. But it would boil off a lot of the river, and in Hiroshima it was just like a dry riverbed because it evaporates everything. So that's Hiroshima, 15 kilotons. We have developed bombs since then. Right? There are 1,000 kilotons in a megaton, and today a normal-sized nuclear weapon is 3 megatons, 3,000 kilotons. That's 15. The Russians had a 50 megaton weapon, that we're not even going to go there. But a 3 megaton, the normal sort of standard nuke in our arsenal, looks like this. It blows up, it flattens everything up to almost Baltimore, those concentric rings. Like Norman Cousins predicted, nukes in World War II were meant to destroy part of a city. These are meant to destroy countries. And if, in the event of a nuclear response, we fire between 12 and 1,500 of these at Russia or China, is where they're targeted to. 12 or 1,500. Scientists have said it would only take about 380 nuclear detonations to end life on Earth. 380. We have 4,000. Well, some of them are not deployable, but anyway, I won't get too technical. Yeah, so that's scary. When people think about nuclear weapons, it's like, well, Hiroshima, it's a thriving city today, but That's not today, right? This is today. Much more destructive. I don't want to end on like a bummer like that. So like, anyone have any other? Yeah. Yeah.
Hi, I'm Dr. Elaine Soreo, and I've taught at Trinity. My mother went to Trinity, and my mother went to Trinity during the time all of this was happening, during the start World War II, and my mother graduated in '47 in chemistry. Now, to that end, we have 450 plus, or I've forgotten the number, of members of Congress alone. Of course, we've got 100 senators. And I have to say that it's really very sad because there's a large preponderance of our elected officials who come from the American population that really have scant understanding of any of this, just any of it. And because of that, you have people dealing with everything on a very visceral level with no knowledge base of understanding of where everything can go or does go or what happens. And there's bravado, and we've already seen a lot of things happening in our country. And it's not just the last 10 years, it's been going on for quite a while. It's a cumulative process. So my biggest concern, and I'm the associate rector of a private Ukrainian university that's operating, and I know for a fact of what's going on in Chernobyl, what's going on in Zaporozhye, and Zaporozhye is the major nuclear site for Europe, and the threats to that, and the Russian threats to destroy it, and what that means not just to Ukraine but to Europe. I mean, the threats are very, very real, because I work in other areas that confirm those threats. So I just really, I hate to sound despairing, but
Well, can I say so on that?
we can all be Norman Cutler.
Yeah, I mean, you can be activist. I mean, the problem, you're right. My own mother, she's not watching the live stream, I hope. But, you know, I've worked on nuclear stuff for 15 years, and at one point she's like, but we don't have nuclear weapons anymore, right? The Cold War's over. It's like, no, the Cold War is over, but we do. There's still as many as there were there. But here's maybe it's not positive. But you mentioned Ukraine. There are 2 countries in the world that have voluntarily given up nuclear weapons. One of them is South Africa, which had nuclear weapons and gave them up. One of them is Ukraine. In 1994, at the collapse of the Soviet Union, Ukraine was the 3rd largest nuclear state in the world. US, Russia, Ukraine. And no one wanted Ukraine to have nuclear weapons at that time for a number of reasons. So long story short, a deal was cut that in exchange for Ukraine giving up its nuclear weapons, we would pay them hundreds of millions of dollars, and those weapons would be transported back to Russia to be dismantled. And yeah, which, you know, who knows if that actually happened. But in exchange for Ukraine doing this, they would get a defense agreement from the United States and Russia that if any country should, threaten their territorial sovereignty, both Russia and the United States would come to their defense. And what do we have? Russia breaking the agreement and the US sort of breaking it by not actually stepping in to defend them. But there have been cases where countries have given up nuclear weapons. There are some countries that have declared nuclear-free zones. And there are lots of countries that could develop nukes. Canada has a program but have chosen not to. Indonesia, chosen not to. So there is some hope. There's, maybe things are moving in the wrong direction, but you can write your congressmen and senators and maybe, push this a lot more, especially the one positive thing that might come out of all of this, war, especially with Russia and Ukraine, is now this is back on people's minds. weapons, right? The thing that was like the Cold War's over, the nuclear threat's gone. Well, it's back. Sorry to say. And we need more people working on this. Is why I, give public talks about these sorts of things, not just about cool Oppenheimer movie, but I want to scare you with this sort of thing. And at least our students, maybe I'll end on this note, our students do get to take a course taught by me on nuclear weapons and arms control, an upper-level course where there are less than 1% of the universities in the United States teach courses on nuclear weapons, and I haven't found any other women's colleges that do. So Trinity teaches on this now. Not to stoke my own ego there, but all right, maybe. Yeah, so we have a partnership now with the Middlebury Institute out in Monterey, California, where they run a nuclear non-proliferation and terrorist and security threat program. And Trinity has a partnership with them where we send one student each summer to go work with them on these non-proliferation issues, to do exactly what we're talking about here. They get generously paid. They are working for them and have amazing experiences. They tackle a project and have some real outcome from here. And we're hoping, we've only had this will be the third year now, and one of the previous students is pursuing a career, hopefully, in these sorts of non-proliferation, anti-nuclear fields. So there is a direct line of like what they learned in the classroom, these partnerships we have, and now she might join the Bureau of Arms Control, at least is in the running for. So I'll let you know if this comes through. That would be a huge success. Always, always. Yeah, here we are. And thank you all for coming back.